Cool, thank you. This was originally going to be an outdoor demo, but given the weather, I've moved it inside. Turns out my rover doesn't need GPS, so I'm fine to run in here. So I've been getting into ROS for the last couple of months whilst building up my rover here. This rover is derived from the Dagu design, so you'll see some similarities to Tridge/Reese's rover that they've been using earlier. So what I've done with this rover is it's got a bunch of stuff going on in it. So I'll just explain what's going on in the rover first, then I'll do the demo. So what I've got going here is I've got ArduPilot running inside the rover. I've also got a Raspberry Pi 4 running ROS2 Jazzy. And the way I've done it is I've got a LiDAR on top of the rover, 2D LiDAR, and that feeds into the Raspberry Pi. And ROS on the Raspberry Pi will, as the rover moves around, ROS will automatically generate a map of the area using data from ArduPilot. So ArduPilot, in this case, ArduPilot's providing the IMU and the odometry data into ROS. ROS will then fuse that with the LiDAR scans and hopefully create a fairly accurate map of this room as I run it around. And I'll also show a small GUI I've been working on as well, a prototype ground station that you can use under ROS. What else have I got in here? In terms of the connection between the flight controller and the Raspberry Pi, I'm running a PPP link, and I'm running both DDS, that's what ROS2 uses for communications, plus a Mavlink connection in there as well. So, and I've also got a live video feed from the front of the rover as well, running over all this. All of this communication's been done via the Wi-Fi at the network here, within a zero-tier VPN. So, what I've got going here is my little ROS GUI. This GUI here, that's all from ROS data. There's no Mavlink there. That's straight from the micro ROS gateway running on the Raspberry Pi. At the moment, there's not too much data exposed under the ROS topics. Hopefully I'll change that and add a few more in the next couple of months. We can get things like GPS data, longitude, latitude, which isn't showing here because I haven't got a GPS signal. I can get basic battery data, voltage, current, percentage voltage remaining, arm, disarm status, flight modes, fail-safes, if any, as well as in terms of controls, I can arm and disarm the vehicle from here, as well as set some of the basic flight modes. As a stretch goal for this demo, I was hoping to be able to have ROS control the robot as well and do some fancy path planning. Unfortunately, I didn't get quite as far as that for this demo. So this is just going to be under control by my RC controller here. And it'll be ArduPilot feeding the data into ROS and ROS creating the map of this room. So if I get RViz up and running, so here's what the laser rangefinder currently sees. So I'll just expand that out a little bit. There we go. So what I've done here is I've artificially limited the rangefinder to about 6 meters distance, just so it's easier to see it as it visualize it as it goes running around here and adds to the map. So I've got within the ROS framework, I've got the cartographer, so the cartographer ROS node doing all the mapping here and fusing the data. Then I've got the nav2 stack running, ROS node running as well. So in terms of this, what Cartographer does is that will generate the map for us. And then the nav2 ROS node will do all of the calculate the paths and the object avoidance and so forth for path planning for the robot. So in this case, nav2 is running, but it's not actually doing anything because I'm just running manually. So what I will do is I will run this through and I'll see how well I can operate this from up here using FPV. All right, so I will arm it. Come on, are you going to arm? And of course, it refuses to arm now. Let's have a look. Why is it? Let's try again. There we go. I just had to hold the receiver differently, or transmitter. All right, let's go. And we'll see how laggy the video is. So we've reached the end of there. You can see the map sort of, I'm going to have to zoom out that map actually. Hold on. Whoop. Okay, the map's jumped a little bit. Yes, sometimes the map will jump a little bit if the rover's been running for a little while. So let's turn that up a bit. All right, let's see if I can. So you can see as it moves along at the top there, it's gradually expanding out the map. You can see the red dots there are sort of the live feed from the LiDAR. Am I past the last table? Keep going? All right. Whoop. There we go. Yeah, there's a bit of lag with the video. There we go. Just run along the back there. And try and avoid knocking into anyone's chair. And that's the end. All right, I'll just move that map again. So you can see it's got the back of the room there now. It's come along the back and it's mapped all the back. And now I'll come down this side and complete the loop. Then I'll go up the middle as well, and we should have a fairly decent map of this room from the LiDAR. All right, so I need to turn around. All right, around we go. Oh, there you are. There we go. And it's reasonably accurate now that it's come back around. There's not been too much slip. Now I will come up the middle. Come on. Round we go. There's the middle. Up it comes. Oh, I think that was my backpack too. All right, let's try that again. There we go. Come back down the other side. And thank you for not sort of trying to hit the rover as it comes by. All right, let's come back. Nearly there. Come on, there you are. So bring him back round again. All right, there you go. All right, let's have a look at that map. Oh, that doesn't look too good. Yeah, so one of the fixes I need to tune up at the moment. Yeah, as the rover goes around, you'll start seeing some offsets with where it thinks it is, and the map, as a result, will start getting offsets in the map if it hasn't revisited the area in a while. I do need to take a look at the cartographer settings. Go.
I do notice some latency in when it's turning. The points that it's seeing shift, they get rotated. Is that possibly?
Quite possibly. I've been struggling with getting the frame coordinate conversions between ArduPilot and ROS correct. The yaw may be reversed. That may be wise, or maybe something going on there. That
it would be impressive if it still worked with the ArduRover.
Yes, very true. ROS. Doing frame conversions between ArduPilot and ROS has been a bit of a trial by fire. I still haven't completely got it. There's some patches I want to make it easier for other people. So basically we had all of this was running locally on the poor little Raspberry Pi 4. That includes the map generation, the video that was all compressed and transmitted via the Pi as well. Had some Mavlink telemetry in the background. Had the ROS2 DDS bus as well. In future, I'll add the navigation 2 as well. So the Raspberry Pi is doing a fair amount of stuff, and even though it's only a Raspberry Pi 4, it's keeping up pretty well with all of this. And I think that's about all I have to show you today. I'm not sure if we've got time for any questions. Yeah, if anyone's got any questions. Yep, Brian's got one.
So I had difficulty tuning cartographer and Siddle. How much worse was it on the real hardware? Did it work out of the box?
It did not work out of the box. It definitely did not. Cartographer, I'm finding very, very fiddly to tune. I need to record some ROS bags to have some data to play back. Because half the time it's been a case of the only way it would be tune cartographer, run the robot through my house, tune it a little bit more. I am finding I think there's some lag or time difference between the LiDAR readings and the IMU readings, which I need to investigate. I did have a nightmare of a time getting the time sync correct between the different ROS nodes. So I found ROS needs to have very tight timings between all the data feeds coming in. And there were some little lags in the system that I needed to fix up, or in some cases just fake some timestamps to get things running along. So that was interesting. But yes, tuning is hard. I kind of got it working here. I find it's fine in the short term, but once you've got cartographer running for maybe more than a few minutes, you start to get jumps in the position. So I'd be curious to see if that's a problem with jumps in ArduPilot's position, or if it's cartographer trying to do something weird after it's got the fused data. Or it could just be because I'm not running a GPS here, so ArduPilot's having a bit more of a difficult time with its position estimates. Yeah.
Thank you.
Are you running odometry on the wheels, or is it just?
Oh yes, I forgot to mention that I'm running wheel encoders on the wheels. That's feeding into ArduPilot, so that's where my velocity calculations are coming into ArduPilot. And probably the only reason this does in fact run indoors is because I'm getting very good velocity estimations from the wheel encoders. So the GPS, I only need that for my positioning source in the EKF.
You might see a little bit of slip on the wheel odometry because it's a skid steer as it goes round, and that can sometimes throw the corners off.
Yeah, you're right. Yeah, that could be an issue. Yes.
Yeah.
Wonderful. Thank you very much, Stephen. Round of applause, everybody.
Thank you for joining us for the Ardu Pilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.